Think of some of the greatest achievements in our history. It took us 5 million years to discover fire, and it would be another 2 million until we harnessed electricity. And a little less than 100 years after that to create the first computer.
You've got mail.
A few decades later, and we are now teaching machines how to learn from our behavior in the hopes that we can create a more fair and equitable world. Artificial intelligence is being used to identify and treat disease.
Researchers at Google used an algorithm to analyze eye scans
to
as a
surface
method
you
for
more
predicting heart
personalized
disease.
recommendations. And it's present in everyday products such as phones and computers. However, there's still a lot that we don't know about artificial intelligence. We are finding instances where algorithms are perpetuating biases.
New York insurance regulators have opened an investigation into United Health Group over an algorithm they say is racially biased.
A federal study of more than 100 facial recognition algorithms found that Asian and African American people were up to 100 times more likely to be misidentified than white men. So that is clearly concerning.
And so the focus of this primer will be to explore how bias is introduced into our data-driven decision-making, what types of biases there are, and the techniques you can use to mitigate bias in your own data-driven decisions and processes. And with that, let's get it started.
We're at the dawn of a new age, the age of AI.
Artificial intelligence.
Artificial intelligence.
The machine knows! Stop yelling at me! No, stop yelling!
Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone?
And we are back with a kick-ass attitude to discuss how we can take bias into account in our AI processes, but also in our decision-making. First, we need to frame the problem correctly. The more minds on a solution, the better. Work fairness into the goal. Most business ML or AI solutions are aimed at maximizing a goal, such as profit. However, effective business solutions tend to exploit opportunities that are beneficial to some and not others. Is it okay to maximize profit while alienating a certain customer segment? Second, understand that your data is biased. The data we have is an outcome of a process. While we like to believe that the data processes are unbiased, this is not true because the majority of these processes are set up by humans, but this is okay. Knowing of and identifying bias in your data is the first step in making a more informed decision. Other questions you need to ask? What data are we missing? Think of customer purchase history. We have all the data for customers who have been in our stores, but we are missing data for those that haven't been. This also relates to selection bias. In an analysis or data process, make sure to collect data on all represented groups. Is the data correct? This is one of the most important questions. Does the data match to some type of internal standard or report within your organization? And lastly, understand that your data is historical, and that not all trends carry forward, nor should they be carried forward. Be willing to leave some data out of an AI process because you know it may unfairly impact a customer segment based on historical trends. And the last main point, challenge your assumptions. Is your hypothesis educated or biased? We all believe that our hypotheses are well informed, but we are always missing information. Do your due diligence and try to be as informed as possible. And when you can't, rely on others. Be willing to be wrong. We often are hesitant to admit failure. However, when it comes to data, we want to let the numbers speak for themselves and not nudge them in the right direction if we're not happy with an outcome. Think ethically. Just because you can doesn't mean you should. Even if you have location and purchase history, would you be okay with a company learning all of your movements in order to sell a product? Maybe, maybe not. But it's a discussion you need to have before using customer data. With that said, thank you for coming along this data journey. There's plenty more to learn, but I wanted to provide you with a small peek into the world of bias in artificial intelligence and data. See you next time.
Many tech companies approached facial recognition with caution. In fact, in 2011, the then chairman of Google said it was the one technology the company had held back because it could be used in a very bad way. And think about that. It was too Pandora's boxy for Silicon Valley.
Joy Buolamwini has been researching prejudice in tech, and her work is on show in this new exhibition at London's Barbican.
So this is the experience I had that kind of started it all. I was a grad student at MIT working on a project that used face detection, and you saw it work well on my friend's face. When it came to my face, it didn't work so well until I put on
the white mask on.
Yes, the white mask, right? And
then it worked perfectly.
Another report that showed with self-driving cars, when they tested pedestrian tracking, it was less accurate on darker-skinned individuals than lighter-skinned individuals. I started looking at the data sets. I learned that for some of the largest data sets that have been very consequential for the field, they were majority men and majority lighter-skinned individuals or white individuals. So I call this pale male data. And if you have a lot of pale male data, you're destined to fail the rest of the world.